Hello everyone again. This is another video of the inference subject, and this time I'm just going to cover the concepts behind what it's called statistical hypothesis testing. Okay, so in this video I'm going to briefly explain with this example that you are seeing in the slide what is a statistical hypothesis testing about and why it is an essential tool for science to discard the status quo if the empirical data is not compatible with the status quo. Remember, the status quo is the null hypothesis that we saw in a previous video. And then as this probability that the status quo supports the empirical data is really low, we reject the null hypothesis and accept the alternative hypothesis. Remember that we reject the null hypothesis when the p-value is below a threshold that we call the significance level. Remember also that the p-value is something that is subjective, okay? It's a result of a mathematical operation, as we are going to see. However, the significance level or the confidence level, alpha, here with a value of a 5%, is chosen by the scientist. In other words, it's subjective. It's something that the scientist decides previously of the experiment. So statistical hypothesis testing are all the same. Although the formulas are different, we are always computing a statistic. We are always computing a quantity that it's going to be centered on, in this case, for example, the zero value, okay, of a normal distribution, but it can be another distributions. For example, a T student, it could be an F of Snedeker, and so on, a W also. But the important thing here to know is that at the result of a statistical hypothesis testing, it's always going to be a p-value. Okay, it's always going to be a p-value. And the p-value, it's the area, it's this red area of the integral in this test, in this case, because the test is right, okay, we are going to see that it is essential, it is critical to know what is the sign of the alternative hypothesis. In fact, when you are coding this on R, you put on R alternative greater, alternative less, or alternative two-sided, okay? So this is the sign of the alternative hypothesis. And why this is the most critical thing in statistical hypothesis testing? Well, because the area of the integral, okay, this area here that you can see on red, this is the p-value, okay, and this threshold is going to be put at the right if this is higher than, it's going to be here at the left in this is lower than, and it's going to be present on both sides of the distribution if it is not equal. Why? Because we say that if this statistic, if this formula, okay, that you can see that it is just a theta value, a set value that we saw in the statistics subject, okay, here, remember, the sample mean, it's a random variable, okay, so this is the sample mean minus the mean parameter, okay, here in this case 52, you can see how this mean has been substituted in the example here by a 52, okay, so we are centering basically this random variable, this random value. Now the mean is going to be 0, and we are going to divide this quantity by a standard distribution. And why the standard distribution is here the populational variance divided with respect to the square root of the sample size? Well, because if you remember, the probability distribution of the sample mean, this is for topic 1, the variance of the probability distribution of the sample mean was just this quantity, was the standard deviation of the parameter, the standard deviation parameter divided with respect to the square root of the sample size. Okay, so this is the reason why we have this formula, and it is always the same. First, we center the distribution on 0, and then we standardize this value, this statistic, just to make it compatible with a normal distribution 0, 1. So if this statistic, okay, here you can see the theory is mu 0, and the standard distribution 10, okay? So if this value it's compatible with this hypothesis, in this case, mu lower or equal than 52, this theta value, it's going to fall on the wide region. Okay, it's going to fall in the wide region that we define as the acceptance region. However, if these signs were changed, the acceptance region would not be in the left, it would be on the right. And this is what you need to know, because it depends on every example that we are going to have the acceptance distribution, the acceptance region on the right or on the left. Okay, so here in this case, the theta value, its value is 2.12. So the p-value, that in this case is 0.017, it's going to be the integral of the distribution from 2.12 to infinity. Why from 2.12 to infinity? Because we have this sign over here. Okay, so this is telling us that the probability that the empirical data supports this hypothesis, the null hypothesis, that is that the mean of the sales is lower or equal than 52, is just at 0.0170. In other words, the risk of rejecting the null hypothesis and being wrong according to the data is just at 1.7%. So as our significance level is at 5%, the amount of risk that the scientists, in other words, us, are assuming in this case of being wrong is at 5%, as the p-value is 1% and it's lower than 5%, then we reject the null hypothesis and accept the alternative hypothesis. Okay, so all the statistical contrast testing are the same. Okay, first we need to represent these things accurately. Then we need to see in which case are we. Okay, if we know the standard distribution and it's the mean, is the first case. If we don't know the standard distribution and it's about the mean, is the second case. If instead of the mean we have the proportion, is the third case. If we have to compare two means, is the fourth case. If we have to compare two proportions, is the fifth case. And if it is not a parametric test, we need to see in our subject whether it is about seeing if a random variable is normally distributed, then the Wilkinson test. Seeing if two variables are independent, then it's the correlation test. And finally, we can see whether if these groups are not normally distributed. Remember that the sample size needs to be higher than 25. Okay, if this is the case, for example, here is 200. If we have two means and they are not normally distributed, you can also use the median test that you have at the end of the slides to determine whether one is higher than another. Okay, so this is basically the statistical test, but they all follow these 5 steps. Everyone. First, we represent this, then we see whether we can apply the test and we chose the test, then we compute this statistic. Having this statistic, automatically we have the p-value, and we are going to reject the null hypothesis if the p-value is below our confidence level. But be careful, okay, because if I change these two signs, okay, if instead here of lower than, here the null hypothesis is higher or equal than, and the alternative hypothesis is lower than 1, the result, this 2.12, it's going to be the same. Everything's going to be the same. However, as you can see in this new slide, okay, now the p-value, it's going to be 0.983. Why? It's obvious, because this month the customers has spent more money than 52. Okay, so this data, it's really compatible with the null hypothesis. Consequently, we cannot reject the null hypothesis. Okay, so be careful with the signs. This is an example of a left tail test, and now in this case the p-value is going to be all the area below this blue line in the normal distribution. In other words, this is a value that is highly compatible with the null hypothesis. And finally, this is the last case of a statistical hypothesis testing. We can have equal or different. Okay, if in the case of equal and different, you can see here in the slides, we are going to not being able to reject the null hypothesis if the value of the statistic, in this case 2.12, belongs to the acceptance region. Okay, the width of the acceptance region is going to be totally correlated with the significance level. If the significance level is lower, then we are going to have a lower acceptance region, and vice versa. Okay, so for example, in this case, the theta value 2.12 has fallen into the rejection region, and hence this value, okay, this is a 0.34, lower than the confidence level, and we are going to reject the null hypothesis. So remember, this is always done in the same way. You need to really rigorously follow the steps, and once that you have followed the steps, you can see the set value. You have the p-value associated with the set value. You just have to see whether this p-value is lower than the confidence level. Nothing else. So once that you have done that, then you know what to do. Accept the alternative hypothesis, or not being able to reject the null hypothesis. Once that you have done that, you know how to move strategically in your company. What is the best move in your company? You need to support this portfolio, you need to merge with a competitor, or whatever in the case. So I hope that everything is clear, and see you in the next video.